All right, so our next set of notes in probability are probability distributions and frequency tables. So frequency table is a table that displays data and this is really weirdly worded, but it's a data display that shows how often an item appears in a category. So basically, it's a table that shows how frequently something appears in a certain category. And the relative frequency is the ratio of the frequency of the category to the total frequency. Right? So essentially, relative frequency is our probability. In this situation, it's just labeled as relative frequency since we're talking about frequency tables. So we can think of it as a type of probability. All right, so our first example, the students surveyed music preferences and are organized in the table. So what is the relative frequency of preference for rock music? All right, so our first job or step here is to figure out the total number of people that were surveyed. So we're just going to add all of these together. So they surveyed 40 people. So 40 is our total here. And then we're talking about frequency for preference of rock music. So you go to the table and you find rock music and its frequency was 10. So 10 out of the 40 people preferred rock music. So if you simplify that, it is 1/4. So 1/4 of the students surveyed preferred rock music. Okay. So on to the next one. A student conducts a probability experiment by tossing 3 coins, one after another, using the results below. So we want to find the probability that exactly 2 heads will occur in the next 3 tosses. Okay. So first, we're going to figure out what our total frequency is. So we're going to add all of these together. 5 plus 7 plus 9 plus 6 plus 2 plus 9 plus 10 plus 2. So 50. Okay, so we have a frequency of 50, but we only want exactly 2 heads. So we're going to look at each time where only 2 heads occurred. So this one has 2 heads, this one has 2 heads, this one has 2 heads. So now we're going to add these 3 numbers together. So 7 plus 6 is 13, plus 2 is 15. So we're at 15 out of 50. But if we simplify that, we get 3/10. So the probability of getting exactly 2 heads is 3/10. Okay. Moving on. All right, so a student conducts a probability experiment by spinning this spinner, spinning a spinner with the numbers 1, 2, 3, and 4 on it. Using the results in this frequency table, we're going to find the probability of the spinner pointing at 4 on the next spin. So once again, add up the total number of frequencies. So he spun this 100 times. So it's out of 100. And then we're finding 4 on the next spin. So you go to 4, add a frequency of 18. So 18 out of 100, but that simplifies to 9 out of 50. The probability of spinning a 4 is 9 out of 50, which eventually, if you spin this enough times, it should work out to be almost 25%. Obviously, that's not happening right now. As long as all of the spaces in the spinner are equal, eventually, after enough spins, it will work out to be that it is almost 25% exactly. Theoretically, doesn't always happen. All right. So a probability distribution shows the probability of each possible in a frequency table. So essentially, it's taking the data from a problem and writing it as a frequency table. So in this problem, 50 archers shot 6 arrows each at a target. 3 archers hit no bullseyes. 5 hit 1 bullseye. 7 hit 2 bullseyes. 7 hit 3 bullseyes. 11 hit 4 bullseyes. 10 hit 5 bullseyes. And 7 hit 6 bullseyes. That's a tongue twister. And then we want to find the probability distribution for the number of bullseyes each archer hit. All right, so we're going to make a frequency table. So this is the number of, and I'm just going to abbreviate this as BE. And then this is number of hits. All right, so the options for bullseyes is 0, 1, 2, 3, 4, 5, and 6. And now the number of hits is just filling in how many. So 3 hit 0, 5 hit 1, 7 hit 2 and 3, 11 hit 4, 10 hit 5, and 7 hit 6. Okay. And that's it. That's our probability distribution. We've created a frequency table to represent how everything was distributed. All right. So on a math test, there were 10 scores between 90 and 100, 12 scores between 80 and 90, 15 scores between 70 and 79, 8 between 60 and 69, and 2 below 60. So what is the probability distribution for the test scores? All right. So for this one, let's make our table vertical. So this is test scores, and this is number of students. All right, so they're between 90 and 100, 80 and 89, 70 to 79, 60 to 69, and then below 60. All right, so there were 10 scores here, 12 here, 15 here, 8 here, and 2 here. So then that's the probability distribution for our test scores. And I believe that was our last example for this one.